Prime and composite number. A number that has exactly two factors, 1 and the number itself, is called a prime number. So, a prime number is that number which comes in the table of 1 and in the table of itself only, means they do not come in any other numbers table. They are divisible by 1 or by the number itself, like 2. 2 comes in the table of 1 and 2 comes in its own table, that is table of 2. Therefore, there are only two factors of 2. Similarly, 3 comes in the table of 1 and in the table of 3, which means 3 is divisible by 1 and 3 only. So, only two factors are there for 3 also. 5, it is divisible by 1 and it is divisible by 5. There is no other number by which we can divide 5 completely. Thus, 5 also have only two factors, that is 1 and 5. Therefore, we can say 2, 3, 5. All the three numbers are prime numbers. There are many more prime numbers which are only divisible by 1 and itself. A number that has more than two factors is called a composite number. So, those numbers which comes in the table of any other number also, they come in the table of 1 and in their own table, but along with it, if they come in any other numbers table also, then these numbers are called as composite number. Composite numbers are multiples of some numbers like 4, 6, 8, 10 and so on. Here you can see that 4 comes in the table of 1, in the table of 2 and in the table of 4. So there are more than two factors of 4. Therefore 4 is a composite number. Similarly 6, it comes in the table of 1, in the table of 2, in the table of 3 and in the table of 6. Therefore, there are 4 factors of 6. So, 6 is also a composite number. In this way, we can find many composite numbers which have more than 2 factors. Now, just look at this number 1. There is only one factor for 1, that is 1 itself. Therefore, 1 is neither a prime number or nor a composite one. Therefore, we can say that 1 is neither prime nor composite. Let us take two numbers, 12 and 18. Now write all the factors of 12. So the first or the smallest factor of 12 is 1. Then we have 2, 3, 4, 6 and after that 12 itself. Now write the factors of 18. So 1, 2, 3. After that we have 6, then 9 and then 18. So you can observe that few factors are common in both the numbers, like 1. 1 is a common factor of all the numbers. Then we have 2 as a common factor here, then 3, then 6. So we can say that common factors of 12 and 18 are 1, 2, 3 and 6. So the factors which are common in two or more numbers are called as their common factors. Now let us take two more numbers, 17 and 23. Now write the factors of 17. So we have 1 as the factor of 17 and 17 itself as the factor of 17 because 17 is a prime number. Now write the factors of 23. So 23 is again a prime number. There will be only two factors, that is 1 and 23 itself. Now here you can see that the only common factor is 1. There is no other number which is common in the factors of 17 and 23. Such numbers which have only 1 as their common factors are called as co-prime numbers. So we can say 17 and 23 are co-prime numbers. You can see some more examples of co-prime numbers like 5 and 8. So for 5 we have two factors, 1 and 5. 8 we have factors 1, 2, 4 and 8. So here again you can see that we have only 1 as their common factor. So the only common factor is 1. That is why 5 and 8 are co-prime numbers. Now look at the question given here. We have to find all the common factors of each of the following pairs of number. So the first pair given to us is 8 and 14. So write the factors of 8. Factors of 8 are 1, 2, 4 and 8. Now write the factors of 14. So factors of 14 are 1, 2, 7 and 14. Here you can see 1 is a common factor and 2 is also common here. So common factors of 8 and 14 are 1 and 2. The next pair is 36 and 51. So write down the factors of 36. It will be 1, 2, 3, 4, 6, 9, 12, 18 and 36. Now write down the factors of 51. So here we have 1, 3, 17 and 51 as the factors of 51. You can see by dividing the 51, 51 is divisible by 3. You can check here, 5 plus 1, 6. So 6, the sum is divisible by 3, which means 51 is divisible by 3. And when we divide 51 by 3, we get 17. 17 threes are 51. So here 1 will be the factor, 3 will be the factor, 17 will be the factor, and after that we have 51 as the factor of 51. So here the common factors are 1 and 3. Therefore, common factor of 36 and 51 is r equals to 1 and 3. Now the next pair is 11 and 17. So for 11 we have 1 as a factor and 11 as its factor because 11 is a prime number. Next number is 17. Again 17 is a prime number, so the factors will be 1 and 17. Here the only common factor is 1. So common factor of 11 and 17 is equals to 1. So we can say that 11 and 17 are co-prime numbers because they have only 1 as their common factor. So 11 and 17, they both are co-prime numbers. Prime factorization. A factorization having each factor as prime is called the prime factorization of the number. When we multiply all the factors of the prime factorization, then we get the original number. There are two methods to do prime factorization: the division method and the factor tree method. Now let's discuss how to do prime factorization using division method. Let's take a number 36. Now as we can see that 36 is an even number as it has 6 at its ones place, which means this number is divisible by 2. 2 is the smallest prime number. So firstly we will divide this number by 2. Write 2 on the left hand side and divide 36 by 2. The quotient is 18. So write the quotient below 36. Now we have 18. We have to divide 18 by a prime number. So the smallest prime number which divides 18 is again 2, because 18 is also an even number, so we can divide it by 2. Now again divide 18 by 2, so we know 2 nines are 18. Write down 9 below 18. Now we have to divide 9 by a prime number. So 9 is not an even number, it is an odd number. So we cannot divide 9 by 2. Therefore the next prime number, that is 3. We will take 3 to divide 9. Write 3 here on the left hand side and 3 threes are 9. Next 3 will be written below 9. Now 3 is itself a prime number, so it will be divisible by itself only. So divide 3 by 3. We will get 1 here. Now here after getting 1, the prime factorization is complete. So 36 is written as 2 multiplied by 2 multiplied by 3 multiplied by 3. So this way we got the prime factorization of 36 using division method. Now if we have to find out the prime factorization using factor tree method, let's take another number, that is 24. Now we have to find out the prime factors of 24. We have to do the prime factorization of 24 using factor tree method. So here we will make two arrows. Now take the smallest prime number, that is 2, to divide 24. So 20, we know that 2 12s are 24. Write 2 on the left hand side and 12 on the other side of the arrow. So here 2 is the prime number and 12 is the composite number. So we will leave 2 as it is and come towards the 12, the number 12. Again start dividing 12 with another prime number. So the prime number by which we can divide 12 is 2. 12 is also divisible by 2. So write 2 here and we know 2 6 are 12. So on the other side we will write 6. Now 2 is a prime number, so leave it as it is. take 6 and again divide it with a prime number. So 6 is divisible by 2. Therefore, write here 2 and 2 threes are 6. So here we will write 3. Now as you can see, we got 6 as the product of two prime numbers. 2 and 3 both are prime numbers. So we will not expand it further and we will stop our prime factorization here. Now mark all the prime numbers. This 2, another 2, this third one 2 and 3. Therefore 24 is equals to 2 into 2 into 2 into 3. This way we can do prime factorization using factor tree method. Now look at the question given here. We have to find the prime factorization of the following numbers using division method. The first number given to us is 57. So let us take a prime number which can divide 57. As you can see that we have 7 at the ones place, which means this number is an odd number which is not divisible by 2. So we cannot take 2 to divide this number. Now let's check the divisibility of 3. 5 plus 7, 12. 12 is divisible by 3, which means 57 is also divisible by 3. So let's divide 57 by 3. 3 ones are 3. After subtracting 3 from 5, 2 is left. 2 and 7, 27. So 3 nines are 27. Now the number we got here is 19. 19 is not divisible by any other prime number because 19 is itself a prime number. So we will divide 19 by 19 itself. 19 19. Therefore 57 is equals to 3 multiplied by 19. The next number given here is 56. So divide 56 by a prime number. You can see 56 is an even number as it has 6 at its ones place. So divide 56 by 2. 2 twos are 4. 1 left here, 1 and 6, 16. 2 eights are 16. So we got 28 here. Now divide 28 by a prime number. So 28 is also an even number. So we can divide it by 2. 2 ones are 2. 2 fours are 8. Now we got 14, which is divisible by 2. So 2 sevens are 14. Now we got here 7. 7 is a prime number. So we can divide 7 by 7 itself. 7 ones are 7. So 56 is equals to 2 into 2 into 2 into 7. Next number is 96. So let's start the prime factorization of 96. We will take the first prime number as 2 because 96 is an even number. Now 2 fours are 8, 1 left, 1 and 6, 16. 2 eights are 16. Again divide 48 by 2 now. 2 twos are 4, 2 fours are 8. Now we got 24, which is divisible by 2 again. 2 ones are 2, 2 twos are 4. The next number we got is 12. So divide 12 by 2. 2 6 are 12. Now again we can divide 6 by 2. 2 threes are 6. Now we got 3. So divide 3 by 3. 3 ones are 3. Therefore prime factors of 96 is equals to 2 into 2 into 2 into 2 into 3. In the next question, we have to find the prime factorization of the following numbers using factor tree method. So the first number given here is 72. You can see 72 is an even number, so we will start the prime factorization with 2 first. Divide 72 by 2. So we will write 2 here, and after dividing 72 by 2, the quotient is 36. So write 36 on the other side. Now leave 2 as it is and take 36 and start dividing it with a prime number. So 36 is also an even number. We can divide it by 2. So again write 2 on one side, and 36 divided by 2 will be 18. So write 18 on the other side. Now 18 and divide it by 2. You will get 2 9s are 18. Now 2 is a prime number, and we got the other number 9. Now divide 9 with a prime number. So 9 is divisible by 3. 3 threes are 9. In the last, we got both the prime numbers, so we will stop the division here. Mark all the prime numbers. So this is the first 2, second 2 here, then this third 2, this 3, and the next 3. Therefore, we can write 72 is equals to 2 into 2 into 2 into 3 into 3. The next number given here is 100. So we can divide 100 by 2. So write 2 here on one side, and 100 divided by 2 will give us 50. So write 50 on the other side. Now divide 50 by a prime number. So 50 is again divisible by 2. So write 2 here, and 50 divided by 2 will give us 25. Now we got 25. So we have to divide 25 by a prime number now. 25 has 5 at its ones place. So this is divisible by 5. Here 5 5s are 25. So here we got both the prime numbers now. So we can stop procedure here, the division here, and mark all the prime numbers. So this 2, 2, 5 and 5. Therefore 100 is equals to 2 into 2 into 5 into 5. Next given number is 120. So 120 is divisible by 2. So write 2 here, and 120 divided by 2 will be 60. Now divide 60. We will write 2 here as it is divisible by 2, and 60 divided by 2 will give us 30. Now divide 30. So 30 is also divisible by 2. 30 divided by 2 is 15. Then divide 15. So 15 is divisible by 3. 3 5s are 15. Now 3 and 5 both are prime numbers, so we will stop the division here. And the prime numbers obtained are 2, 2, 2, 3 and 5. Therefore 120 is equals to 2 into 2 into 2 into 3 into 5.